Welcome everyone to lesson 1.8 from Calculus Done Quick, which is the squeeze theorem. The squeeze theorem is a little bit niche, but it has its use, and in this case, it's all we can really use. So let's look at these two functions that we have. We have g of x that is defined as negative x squared, h of x which is defined as x squared, and f of x is defined such that it is always greater than g of x, but always less than h of x for every possible input. So what I've done is I've taken liberty of graphing these two things so we can kind of see what's going on. So our function is in between these functions for all x. So it could be something as simple as a wide parabola, or it could be something extremely complex looking like some sort of sine graph that is shrinking and shrinking and shrinking until it gets to the center and then expanding outwards after that. It could be anything like that. We don't know, but we do know that it's defined to be in between h and g for all of its inputs. The squeeze theorem is the only way that we could say something definitively to answer this question below, which is, what is the limit of f of x as x approaches 0? Well, we don't have a function. I can't directly substitute this in. But we do have some limiting factors. We have the function that's always below and the function that's always above. So let's evaluate those limits and see what happens. Let's evaluate what the limit of g of x is as x approaches 0, and the limit as x approaches 0 for h of x. Now keep in mind that this one is always below and this one is always above. Well, if I directly substitute 0 into the g, I get 0 squared, which is 0, and then the opposite version of that, which is still just 0. And for h of x, I get 0 squared, which is also 0. So let's think about that. G is defined to always be below f, and h is defined to always be above f, but they're both approaching 0 at 0. So that tells us that our function has to approach 0 as well, because it's in between 0 and 0. And there's only one number that satisfies that, 0. What if we had something different? What if g didn't approach 0 and h didn't approach 0? What if they approached different things, like -1 and +1? Well, then f could approach anything that's in between -1 and +1, which is an infinite number of numbers. So we couldn't really say anything definitively about what f approaches. We would be left at a standstill with the inability to do anything whatsoever. So the squeeze theorem, very niche, but has its applications for if two functions, one that is strictly above and one that is strictly below, approach the same value at a given x, and any function defined in between them also has to approach that value. It's a little weird, so it's going to take a little bit of practice to get used to, but if you need help, ask. Other than that, I'll see you in the next video.